Hello, future engineers, subscribers, viewers, and students. Here are series of problems on trigonometry, particularly on sum of interior angles, closed polygons, and specific names of angles. So we have series of problems here in relation to or applications of the preceding topic in trigonometry. So the first problem, find the sum of the interior angles of a closed decagon. A decagon is a polygon with 10 sides, and the sum of the interior angles is given by or derived in the preceding slides as quantity n minus 2 times 180 degrees. So this is the formula for the sum of interior angles of any closed polygon. So for part A, since it is a decagon, then we just substitute n is 10. So summation of interior angles of a decagon is equal to quantity 10 minus 2 times 180 degrees. So that is 8 times 180 degrees. So summation of interior angles of a decagon therefore is 1440 degrees. So that's it for problem A. For problem B, the sum of the interior angles of a certain closed polygon is 1800 degrees. Which polygon is it? So we are going to determine the number of sides, and from that number of sides we name it. So it may be an octagon, an onagon, decagon, ondecagon with 11 sides, dodecagon, uh, tridecagon if it has 13 sides, quadridecagon or uh, tetradecagon if it has 14 sides, or quindecagon if it has 15 sides, and so on and so forth. So let's substitute. This is the formula for the sum of the interior angles. N minus summation of interior angles is n minus 2 times 180 degrees. Then we equate that to 1800 degrees. So summation of interior angles n minus 2 times 180 degrees equals 1800 degrees. So quantity n minus 2 times 180 degrees equals 1800 degrees over 180 is 10. So n therefore is 10 plus 2, n is 12. And since the polygon has 12 sides, it is called a dodecagon. So dodecagon. Then part C, find the measure of an interior angle of a regular pentagon. So take note, we have a regular pentagon to find the interior angles. So the sum of the interior angles is n quantity n minus 2 times 180 degrees, where n is 5. And since the interior angles of a regular decagon are equal, and there are 5 corners, so there are 5 equal interior angles of a regular pentagon, and we will call it theta. So 5 times theta is equated to quantity n minus 2 times 180 degrees, where n is 5. So that's the analysis. So quantity n minus 2 times 180 degrees equals 5 times theta, where theta is one of the equal interior angles of a regular pentagon. So quantity 5 minus 2 times 180 degrees equals 5 theta. So 3 over 5 is 3/5 of 180 degrees, and theta is equal to 108 degrees. D, an exterior angle is the angle between the prolongation of the preceding side and the foregoing side of a polygon. What is the sum of the exterior angles of closed polygons? So I want you to experience this, and because this sum is constant for any closed polygon, convex polygon rather, A convex polygon, by the way, is a polygon such that when sides are extended, will not cross the polygon. So let's have a polygon in general. So let us say this is the polygon. The number of sides is any, or the number of corners is any. I just want to emphasize that at any corner, the sum of the, so this is the prolongation of the preceding side, this is the foregoing side. This is the exterior angle. So this is the interior angle. I call that theta I, the exterior angle theta E. So take note that at any corner, even if you proceed to this, the sum of the interior angle and the exterior angle is a straight angle. So at any corner, theta I plus theta E equals 180 degrees, where theta I is the interior angle and theta E is the exterior angle. So theta I plus theta E equals 180 degrees. Therefore, if we sum up interior angles and the sum of exterior angles, then since there are n corners, the sum of the interior angles plus the sum of the exterior angles, therefore, is n times 180 degrees, because at each corner, the sum of the interior and exterior angles is 180 degrees. So since there are n corners, then the sum of the interior angles plus sum of exterior angles equals n times 180 degrees. So summation of quantity theta interior angles plus theta exterior angles is n times 180 degrees. So let's break this into summation of interior angles plus summation of exterior angles equals 180 degrees n. We are interested of this summation of exterior angles. So this one, summation of interior angles, is n minus 2 times 180 degrees. Then plus summation of exterior angles, theta is equals 180 degrees n. So let's simplify this into 180 degrees n minus 360 degrees plus summation of exterior angles equals 180 degrees n. So we can cancel out 180 degrees n, and we have these two terms left. This negative 360 when transposed to the right becomes positive 360 degrees. So therefore, summation of exterior angles is 360 degrees. In surveying, the sum of the deflection angles, which are these exterior angles, is also 360 degrees, and that is constant for any closed convex polygon. So remember that. Then one acute angle is 2/3 of its complement. Find the measure of these angles. So we will call the acute angle as theta, and its complement therefore is 90 degrees minus theta. So theta is equal to 2/3 of its complement. The complement of theta is quantity 90 degrees minus theta. So we have 2/3 of 90 degrees minus theta. Expanding the right side, so theta equals 60 degrees minus 2/3 of theta. So combining theta and when transposed to the left plus 2/3 theta, that becomes 5/3 theta equals 60 degrees. So we can solve theta, which is 60 degrees times 3, 180 degrees over 5. So 180 degrees over 5, theta is 36 degrees. So if theta is 36 degrees, then the complement of this is 90 degrees minus 36 degrees. So it is 54 degrees. So the complement or the other angle is 54 degrees. That's why their sum is 90 degrees. F2 supplementary angles have measures of quantity 3x plus 6 degrees plus quantity 2x and quantity 2x plus 84 degrees. Find the measure of these angles. Since these two angles are supplementary, Therefore, the sum of these angles is equal to 180 degrees. So that is 3x plus 6 plus 2x plus 84 equals 180 degrees. So simplifying the left side, we have 5x plus 90 degrees equals 180 degrees. So take note, these are in degrees. 5x equals 90 degrees. So x is 18 degrees. So having found x 18 degrees, the angle 3x plus 6 is 3 times 18 degrees plus 6, so it is 60 degrees. And the other angle 2 times 18, 36 plus 84, 120 degrees. So that's why the angles are 60 degrees and 120 degrees, and their sum is 180 degrees. That's why they are supplementary angles, or each is the supplement of the other. G, final. A certain angle is twice its explement. Find the measure of this angle. So if we denote the angle, certain angle as theta, then it is 2 times its explement. The explement of theta is 360 degrees minus the angle theta. So theta equals 2 times quantity 360 degrees minus theta. This is the explement of theta. Expanding the right side, theta equals 720 degrees minus 2 theta. Combining with theta, 3 theta equals 720 degrees. Therefore, theta is 720 degrees over 3, and that is 240 degrees. So that's it for this video. I hope that your knowledge in trigonometry is increased, even if just a small portion, small part.